Nice job. Remember, if you get extra information, no biggie. On your homework assignment, there will be a few that are just like, here's the triangle, solve everything, and then there will be a few that are story problems. I prefer the story problems because they're faster because you only have to find one thing instead of a lot of things. What'd you get? Nice. Okay, we have one more problem I want to talk about. And this is one that we actually have to try to get right. So everybody's going to draw this very carefully on their paper with me. Especially me. I have to try extra hard because I'm going to be awful at this. So let's say, do you guys remember like the congruence theorems from geometry?
No.
I bet you do. Side, side, side. Remember this? Okay, everybody write these on top of your paper by law of sines. This works with side, side, side. Anybody remember another one? Side, angle, side. As in I have three sides, I have a side, angle, side. Angle, angle, side works. You know what? This actually doesn't work with this. Angle, side, angle it works with. It doesn't work with side, angle, side because side, angle, side is the law of cosines. Make sure I know what I'm doing. Angle, side, angle, side, angle, side, oh, it does. Still no, I don't think. Or side, angle, angle. Yeah, okay. So these two, leave them on there, just cross them out, and then write law of cosines next to them. And these two help with the law of sines. Does anybody remember the ones that don't work as congruence theorems? There's two of them. Well, obviously I wasn't your geometry teacher because it's really easy to remember it when I teach you. Here's one that doesn't work. Okay? Because that's a bad word. Bad words don't work. The other one that doesn't work is the one that goes, ah! All right, the ah one and then the bad word. These don't work at all.
Oh, I remember him talking about a bad word.
A lot of teachers say SSA, and then that one doesn't work, but it is way easier to remember it when I write it like this. Everybody okay with this? Hopefully you're all right, Mariah. Terrifying. Okay, now I'm going to show you an example. So for example 3, I'm going to show you one with a SS, and I'm going to show you how it could actually end up being two different triangles, which one of your homework problems will be like that too. Okay, so we're going to try to draw it really nicely here. Here we go. The first thing you need to know is that capital A is 55.3 degrees. And little a is 22.8 feet. And little b is 24.9 feet. Okay. So I'm going to start this by drawing an angle that looks to me about 55.3 degrees. And I'm not going to make it have huge sides, so watch. I know straight up and down is 90, right? Halfway, can you imagine? So straight up and down is 90, but halfway, how much is that? 45. So we're shooting for something about like that. Okay? So I'm going to make it flat here, and then I'm going to make this kind of going up like that maybe. There's my 55.3 degree angle. That's side A, or angle A. And then I know side B is 24.9 feet. So I'm going to make my 24.9 feet on this side. Okay. Now I want you to draw the exact same picture over here. As close as you can get. There's a side little b. No, I'm drawing the exact same picture again. This isn't,
No, you
No,
put
yeah, you
24.3
put
instead of
24.3.
24.9.
got it. Yeah, no, that's just me being weird. Thank you, Michael. I'd give you a prize, but that's just me. That's not a math mistake. That's just a Lauren Esbaum has problems apparently writing things down.
I was like,
Thank you, though.
is it a new number? Where?
Okay, so everybody understand what I got so far? Where is side A compared to the rest of the triangle? Opposite of this A, right? Okay, so here are two different ways this could work. Either it could be kind of like a skinny triangle and this side is 22.8. Or what? Or it could be pulled out this way. Do you see why A, S, S isn't a congruence theorem? Because I could draw two different kinds of triangles kind of by swinging this length either side. Okay. All right, so now we've got to figure out how to do the two different angles. So we've got 180 minus 55.3, and then how did they get 63.9? Okay, so let's start by figuring out the sine of this one. So I'm going to write the sine of 55.3 over 22.8. Everybody following me so far? Equals the sine of B, whatever that is, over 24.9. All right, cross multiply really quick. Do you guys remember how to find an angle instead? Inverse sine. So with me now, do we have to write this out, this cross multiplication, or can we do it in our heads now? Because I'm going to take 24.9 on my calculator, so should you, times the sine of 55.3. And then what? Divide by 22.8. Okay, this right here, this is the sine of B. So the sine of B equals 0.8979. And to find out B, what do I have to do? Inverse sine. So everybody in your calculator going to hit second inverse sine, 0.8979 in there. I got that B is 63.9 degrees about. You guys get about the same thing? Okay, now which one did we just find? Did we find the B on this triangle or this triangle? Number one or number two?
Number 2.
Number two. You see how this one is bigger than 90 degrees? This one's smaller than 90 degrees, so that one's over here. Okay. Do you guys remember when we used to do the unit circle? Back a long time ago when we did the unit circle? Whew, that's a beautiful drawing right there. Perfectly symmetrical. Wow, guys, looks so good. So good. Now, if I'm trying to find a place where sine equals this positive number, one of my answers turned out to be 63.9 degrees. Where's the other one? Where's the other positive sign? Quadrant 2, right here. And if this distance is 63.9, that's symmetrical, this distance is. So to find it, I'm going to take 180 minus 63.9. And that equals 116.1 degrees, which is this one. So the only time that you need to worry about this is when you have one that is A